Do you want to tell me, Dan, like what you do for Inmotiv and how long
Okay.
you've been with the company?
I am the Vice President of Engineering for Emotiv. I've been with the company a little over 18 months.
Nice.
Uh, I came from the automotive world. I retired from Ford Motor Company, over 30 years of experience at Ford Motor Company in product development. And was introduced to this technology and saw the potential and joined the team, helping to bring my experience in the automotive world to this group and hopefully get them across the finish line and get the product into the marketplace. And I use the analogy a lot, and for many of the folks I get introduced over the course of the last 18 months, that the electric vehicle space is kind of where I'll say, ICE engine space was roughly 100 years ago.
Mm,
And the analogy I use is, 100 years ago, we were making ICE engines as big as we wanted to. And at some point, we figured out we couldn't make them bigger to get more functionality out of them. And as over the course of time, over that 100 years, we figured out how to do more with less, making things more efficiently along the way. And I think the EV space is at that point as well, where we cannot, I don't think the marketplace can continue to advance really, really super high speed motors efficiently, effectively, cost effectively, such that the electric vehicle technology is affordable for the average customer. So I think that's where the multi-speed transmissions are going to start to surface in the marketplace, because you can force multiply the motive force of the e-machine through a transmission and gearing, just like we do in ICE vehicles. And that's kind of what I've depicted here in this a little bit of a presentation for you. You kind of see generically what a motor torque looks like and how a single speed reducer works in the current EV world. It
right.
gives you a very, because it's a single speed, you get a pretty small, I'm going to call it efficiency band, and manufacturers obviously try to optimize the gearing such that the vehicle operates in as much of that region as possible, as long as it can. What a two-speed does, it allows you to expand that quite dramatically, and I would say almost by a factor of two, so that
Mm.
the residency time, if you will, in a high efficiency zone can be dramatically improved. Or and through that you get better efficiency, better range, all those things. Or at the same time, like I said before, you can use the force multiplication of the gearing to also improve performance while not sacrificing any efficiency. So you get basically two benefits. And I think, as I indicated before, I think we're at that turning point in the technology space that gearing is going to start to show up as the next step in EV technology.
Yeah, that's super fascinating.
Uh, just a little bit about the Ingear itself, give you a little history, and I've learned over the course of the 18 months here where we've been and where we're going. In 2019, the company started its initial automotive concepts. By 2022, they had a functional prototype in a vehicle with some amount of functionality and durability. And by this past year, we have further matured the design and moved it from a proof of concept design to I'll say, a production ready intent design with high volume manufacturability and I'll say more automotive requirement focused capability. You can kind of see a little bit of, as an engineer would look at things over the course of time, design durability and part count are kind of inverse and are very synonymous with what we would consider if a particular design would be ready for production. Because as you reduce the part count, maintain functionality, you obviously you know a lot about your design, what's important to it, and how to make it function, and obviously to made at a cost-effective price.
Right. That's great that the part is going down less to go
Yes,
wrong and easier to scale, I would assume too.
absolutely. And the number of part count going down, and then obviously the use of materials, which are kind of highlighted here. But if you think about and I know you've probably seen our transmission on the website, and that particular unit you see on our videos on the website is what our proof of concept design utilized as the core unit. that core unit had, I'm going to roughly 150 parts in it. The current iteration in the, I'll say the production tent design has roughly 70. So we've cut that in half.
Wow.
So as you can imagine, the simplicity, the 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 durability, all the items that would go along with reduced complexity are all evident and present in the current iteration of the design.
Hmm.
Just to give you a little more context of how we've improved the technology, it's more capable and functional than our functional prototype, the current iteration. Um, as I've already stated, it's transformed from a proof of concept to a high volume manufacturable design. We've worked with some of our partners over the course of the last 6 months to make sure that we are capable of doing that, and certainly have gotten uh, feedback that we are on the right track, and it definitely could be made at whatever volume we need it to be at an affordable price. Along with that, we've done some initial durability assessments, both from a CAE point of view and certainly from an initial testing point of view, to make sure that we were capable of using high volume materials while still maintaining the functionality. I think a really important part of the progress we made over the course of the last 18 months is we've gone from, I'll say, prove it via testing to creating models and then having those models validated through some testing so that we can then simulate many things, many scenarios that the transmission could be subjected to and ensure that the durability and the functionality are maintained. We've, like I said before, the part count at 150, as you could imagine, not only was it very complicated at 150 parts, but there was a lot of precision in the materials we used and the dimensions are used in the technology. We've taken that to a whole new level with a part reduction or part count reduction, but also I'll say some of the precision that we didn't really need in a functional prototype have been eliminated, so that it is very manufacturable at its current state. Likewise, initial concept prototypes used whatever material we needed to in order to prove out the function. The current iteration utilizes many of the, I'll say, industry standard low cost materials while still delivering the same function.
Gotcha. What was the main, is there like a specific area of the Ingear that you reduced part count more than another?
I would say the structure that holds the segments and the way that shifts has gone from, and has been the primary reduction in complexity.
Okay.
Um, I will say if you think about I'll say the gears themselves, and the shifting elements, there's probably roughly 70 parts. It's gone down to roughly 20, and that's probably where the significant reduction in part count is.
Wow, that's great.
And just as an example of materials, are some of the materials, as you can imagine, we used all steel and aluminum in our initial functional prototype. Right
Hmm.
now, there are plastics, powdered metals, and net shaped powdered metals and things of that nature. So you can imagine the cost and ease of manufacturing is now embedded into design. So I just wanted to share that with you a little bit of the why we think the number one, multi-speeds are on the horizon for the EV space, and a little bit of where the Ingear has been over the course of the last over the course of the last 4 years.
Yeah, it does make sense that EVs would have to go there eventually. It's just not many people have done it, and it's
No, I would say the few manufacturers have done so with the, I'll say, existing type of transmission technology. That's the
uh,
unique here. It is the most efficient transmission uh, of any kind, and certainly testing has proven that out. And it is more than capable of delivering the same functionality of some of those initial multi-speed transmissions in electric vehicles.
so the test bed you made for the 400,000 kilometers, what were the main wear areas that you noticed after the test was over?
I think one of the clarifications I wanted to give for you on that specific one, the shifting elements, and many of the, I'll say, subsystems in the transmission have been tested, and I think one of the early press releases we had was around the shifting elements of the shifting subsystem was tested to a 500,000 shift cycles.
Hmm.
Our current projections of an entire life of a transmission, that's roughly 3 times, no, 4 times the amount of shifting that we would need to endure over the life of a vehicle. So we test each of the subsystems first before we put the entire transmission together and test it for durability, which we are about to embark on here in the near future. So I think I'm trying to remember exactly what press release, but I want to make sure that you understood the 400,000 cycles was a shift cycles on a component test that we did on the shifting system or shifting element in the transmission. As you can imagine, the shifting needs to endure that repeated up and down through the life of a vehicle. So we've proven
Right.
that part of the system out already.
Are you doing, so that was like version 4 of Ingear?
That was actually in support of setting up materials and the design specifications for the current design, production intent design we call Ingear 5.0. So
Oh, okay.
it informed us of materials and geometry to use in order to survive the life of the vehicle.
'Cause if it, what needed to be repaired, like if you needed to make it go for another, 400,000 or however long you wanted to
Well,
test it for again.
that particular test informed us of geometry and materials, and we selected the geometry and materials that would basically yield infinite life in that particular subsystem. So,
Oh, okay.
right, it informed us where we were on the life curve, the SN curve, as we call it.
That's great.
So we know at least from a shifting point of view, we know the system's probably more than robust to meet the needs of prospective customers out there.
Gotcha. And how do you simulate the shifting of gears and when it's on your testing table or however you set it up?
So I don't know how to describe it. It's a component rig with it's a basically an e-machine that we put our shifting subsystem on, and it just rotates at the maximum shift speeds that we would have the unit, and it just actuates the system, the gears back and forth uh, over the course of several hours. And I think we internally call it the machine gun test because when you hear it, I think there's each revolution of the unit is one upshift and downshift. And as you can imagine, something
Oh,
spinning at 500 RPM, you're doing a lot of shifts in every minute. So
like accelerator testing.
yes.
Wow.
Fortunately, with the design we have currently, to geometry and the materials we're selecting, it no longer makes noise. So it used to be called the machine gun test because when everything was made out of metal, it's wasn't made a lot of noise.
Right. Yeah. Do you simulate like a specific load on the gear, like from say like rolling resistance, things like that? The weight
Well,
of the
in this particular case, in the way our technology works, the shifting happens outside of load being applied to the gear, and that's a little bit.
um,
And you notice if you watch the video, you'll see the gear segments move when they're outside of the chain path. So all the
oh,
shifting happens not under load, and that's hence why we can keep power flow going while a shift is occurring. At the same time, we're shifting gears and going either to low gear or high gear, and so in this particular case, we don't have to simulate a load because the shifting part of the transmission never is under load.
that's right. Okay, that makes sense. What's the mechanical efficiency of both of the ratios? I guess the high and the low.
We were recently doing some testing, and certainly we've had some external partners also do some testing, and we have we're well over 95% efficient. And as we compared to some of our competing technologies, we're more efficient than them as well. In fact, one of the tests we recently run quantified it at a percent, roughly a percent and a half more efficient than what a conventional gear transmission would be.
That's great, and it's a lot more simple too.
Exactly, and that's just when we're comparing one element of the transmission. We haven't had the opportunity to test the Ingear 5.0 for system efficiency yet, but we will get to that in the near future. But even uh, testing some of the sub subsystems or some of the significant subsystem chain differences between a gear transmission and an in-gear. We were finding areas of percents of efficiency. So clearly we're corroborating what some external partners have already tested for us, in which case we were dramatically more efficient than our competitive technologies.
Nice. And how much does the transmission weigh, the in-gear part of it?
Well, I've set an internal target of 50 kilograms, and we're well on track to meeting that.
Wow, very
Uh,
light.
and again, there's a lot of optimization we need to do on I'll say the more conventional parts of it. But our initial estimates are we're well within uh, meeting our target of 50 kilograms.
Wow, nice. Are you excited to be working with Aptera?
Absolutely. I think when you think about the brand Aptera and the vehicle they're trying to produce and wanting it to be the most efficient vehicle on the planet, I think having the most efficient drive line on and drive system, EDU system is fitting, and hence why we're excited to do that with them.
Yeah, it's a perfect fit, really.
It is.
Yeah, I'm
And
excited.
as I alluded to in a couple of those slides, I think in order for them to maximize what they want out of an EDU system, multi-speed's almost a necessity.
Yeah.
Especially, I know that Chris and his team wanting to be capable of cruising down the highway without actually using any battery energy.
Hmm.
I know, and I believe that to be one of their targets, and certainly they're not going to be capable of doing that if they're getting a lot of losses and not being capable of running the motor at its most efficient point.
Right. Is there a certain speed where it kicks over from low to high or high to low?
That will be all dependent on what kind of ratio selections and ratio spread we pick for a particular customer. And in Aptera's case, we're in the midst of still specking out what that looks like for them,
Okay.
balancing all the other things that they have. So that'll be a follow of all that.
Gotcha. That makes sense. So when it's matched to an electrical motor, what's the like efficiency gain compared to, say, a reduction gearbox?
Well, we were doing some studies recently on some alternatives that we might propose to Aptera, and we were seeing double-digit improvements over their current system.
Wow, that's
So
impressive.
yes. Again, it's all about having the right size motor running at the right spot.
Right. Do you have an average cost per unit at this point?
I would say that we're very competitive in cost against our single speed competitors or competitive technologies, and if there might be some amount of incremental cost is uh, more than outweighed by the benefits that it provides. So I think we have some internal targets to meet I'll say a cost benefit, if you will, and we're meeting those. So very small incremental cost for a large improvement in many of the attributes.
Gotcha. Is there any maintenance or oil change kind of required during the life of the vehicle?
No, and like many of the rest of the industry, we're designing the transmission to be sealed for life. So there'll be no maintenance required, no oil changes required.
So there is oil in it to keep everything lubricated, but just
There is.
to replace it.
There is. And one of the items we have found, and as you can imagine, with such an efficient mechanical device, there's not a lot of heat generated. And as such, some of the oil specifications that are in ATF will, at some point in the near future, will address whether or not all those additives and what have you in the ATF fluid is actually necessary. Because we're using basically ATF in our test beds at this moment, but we know we can go to something simpler and more simpler and cheaper, quite frankly, because we don't have to span the same heat spectrum that a gear transmission does.
Right. That makes sense. So you mentioned before the expected life is really just the life of any electrical vehicle at this point.
It is. We're using industry standards of 150,000 mile uh, expected life that manufacturers use in many of the, and we have internal design standards and requirements to support that.
Cool. How does it perform in extreme heat or cold?
We're really not impacted by extreme heat or cold as long as, I mean, as I just mentioned, the lubrication, as long as that functions in those temperatures, we're going to be fine.
Gotcha. So you mentioned the initial test that was sounding like a machine gun due to the metal. So like the new
Yes.
update, is it pretty quiet now as far as like
It's
decibel
it's
level?
it's very quiet actually, and one of the things people will notice of the functional prototype in our test vehicle, then we give them a test drive, is you hear a little bit of noise when the transmission shifts, because at the time we weren't concerned about managing energy when gears shifted. But
Mhm.
with the new design, we've taken that into account, and we control the motion, both upshift and downshift, moving the segments in and out of the chain path such that there is no noise.
What was making the noise prior?
Well, as I alluded to, we have a system now that guides the segment to its position, both whether it be into the path of the chain or out of the path of the chain.
Okay.
Before we had a system where we just, I'm going to use the word throw, but we just moved the segment out of the way without regard to how it finished, if you will, or where it stopped. There was a hard stop, if you will, on the other side that stopped it. We now don't just throw it across; we actually guide it across from one position to the other position, thereby
So it's like a
controlling.
gentle integration when it comes into the rotation.
Yeah, yeah, exactly. I'd say there's a guide that moves it in and out of position and when it's time.
And how does regen affect this, or I guess it wouldn't really.
It doesn't. We have the capability to meet industry standards of regen. I think based on some dialogue with some of the industry experts, 0.3 Gs is always held kind of a maximum that regen you would need to deliver,
Hmm.
uh, at least at this point in time with the chassis brake manufacturers. So we're more than capable of delivering 100% regen for many of the applications we've studied initially.
Okay. Do you know how this compares to an in-wheel motor for, I know that's kind of not many vehicles have had that at this point, but
Well, as it relates to in-wheel motor, an in-wheel motor could never have a transmission. So that would be one item, and certainly the in-wheel motors have a lot of negatives that obviously that manufacturers would have to figure out how to get around. But
yeah.
we're not. I guess our technology is not built for in-wheel motors. Is not compatible with in-wheel motors because that's a very specialized execution of a machine.
But yours would be a lot more efficient because
Oh,
it
absolutely.
would just be like one gear and that's it.
Yes. Yes. Well, again, the in-wheel motors are going to be limited by a one speed because that's all they can package in there. It's so not to mention the unsprung mass problem introduces to the chassis teams of people who have to develop those.
Right.
Makes ride really and vehicle dynamics pretty challenging.
Kind of going back to the maintenance thing, is it something that, say, you drive your EV like 200,000, like super long um, mileage on the car, could it be replaced by the user? Is it pretty straightforward to kind of pop it off and put a new one on?
I think that we would have to work with our prospective customers to figure out what type of specifications they would want for, I'll say, service at the end of life. But like anything, if it was, we incorporated many of the use cases of the end customers into our durability requirements. And if somebody uses it, I'll say on average, it's going to probably last them longer than the 150,000 miles.
Yeah, very fascinating stuff. Those are my main questions I had. Did you have anything else you wanted to share?
Uh, Not really. I mean, I guess this was more of wanting to make sure we shared with you kind of where we are with the technology and how we see it playing out in the marketplace. We think it has a substantial advantage in many fronts. I think the one element we didn't probably touch on is the shifting element. Because we shift outside of the elements are shifted outside of the path of the chain when they're not in contact with the chains. We do
Mhm.
all the shifting under load, and the user doesn't ever notice that it shifts. And there's always tractive force the wheels during a shift. So where I'll say more conventional transmissions have herky jerkiness to them because there's always disruption of the torque flow to the wheels, we do not. So it is the smoothest shifting transmission you'll ever experience.
That's interesting. Yeah, you can definitely, even with automatics on new cars, you can still, you
Yes.
feel it. It's
Yep.
subtle, but you definitely feel it.
And that's the clutches breaking the torque path and then re-engaging the torque path in the transmission as it shifts gears. We don't have to do that because the torque is always present. It's always engaged to the gear and it always transmitted to the wheel. And the shifting happens outside of that.
It just kind of feels like a continuous
It
push
is. It
with no
is.
stop.
Yes. And I have the video of our website. I'm assuming you've seen that though before.
Yeah,
Okay.
yeah.
Yeah, and you can see the segments are moving when they're outside of the path of the chain, and the chain's always providing contact to a portion of the gear such that there's always power flow to the wheels and there's never interruption, so you never have a herky jerky shift.
Yeah, just kind of seeing the chatter in the Aptera community when this was announced, like
Mhm.
it's been overwhelmingly positive. It's like the perfect fit
It is,
on an Aptera.
and I can allude to a little bit of the work we've already done with them, and the other element that is very unique to the transmission, which is it's much quieter than a geared transmission.
Mm,
Some of our initial look at the technology with Aptera. They had their geared single speed in there, and we had put elements of our technology in a different car, and you could tell the chain drive technology was dramatically quieter.
wow,
You could hear the difference as it drove by you.
that's amazing to hear. Well, thank you so much for your time. It's
Sure.
really fascinating to hear more about it, and I wish you nothing but the best for the future and look forward to your updates later this year and next.
And I'm sure we'll be providing them as the development cycle continues with Aptera.
Yeah, of course.
Okay.
Okay, thank you for your time.
Mhm.